So it's an honor for me to share this last session. Thanks again to Vadim and to Alexei for inviting me. And so the first talk will be given, oops, sorry. Just wanted to look at the title of the talk. So yeah, thanks. So the talk will be given by Juliana Szewczkowska and Alexander Kaplin. And the title is Deepfake Audio Detection with Sync and Wavelet Filters in RAWNet 2. So Liana, if you're ready, you can start.
Yes, I'm ready. Can you hear me?
Yes, we can hear you.
Okay, hello, I'm Uliana Zbyszkowska, and I will introduce our conference paper named Deepfake Audio Detection with Sync and Wavelet Filters in RAWNet 2. The authors of this work are Uliana Zbyszkowska and Alexander Khapilin. I'm sorry. Okay, the plan for my talk is as follows. I will begin by informing you about spheres of using deepfake audio in both positive and negative ways. Then I plan to explore existing methods of detecting them and observe data sets with deepfake audio and metrics to evaluate the deepfake audio detection models. Based on that, I will define the aim of the research and propose solution. Finally, I will give some conclusive remarks and describe future work. Deepfake audio has transforming potential in entertainment, enabling seamless dubbing and voice acting, and in assistive technology, enhancing communication device usability for individuals with speech challenges. However, the technology also poses serious threats such as misinformation and identity theft, or create compromising or incriminating recordings of individuals, which can then be used for blackmail or extortion purpose. All these dangers highlight the need for robust machine learning countermeasures. Existing mainstream studies on audio deepfake detection can be broadly categorized into two types of solution. First is pipeline approaches, and second is the end-to-end detectors. Pipeline approaches involve a two-step process with a front-end feature extractor capturing relevant audio features and a back-end classifier making the final detection decision. On the other hand, end-to-end detectors aim to learn the detection task in a single step, leveraging deep neural networks to map raw audio data directly to the detection decision. Machine learning algorithms' ability to distinguish real from fake audio relies on diverse real-life training data. Early data sets were crucial for developing countermeasures for automatic speaker verification systems, enhancing security measures. The ASV spoof challenge has further advanced ASV technology, focusing on detecting various types of attacks, including deep fakes. However, these datasets lack real-world scenario representation, impacting model performance. To address this, researchers have collected an in-the-wild dataset in real-world conditions, comprising audio deepfakes for public figures and politicians. Other datasets like the fake or real dataset and Wayfake have been developed, each with its advantages and limitations shown on the slide. To observe the differences in real and fake audio of described datasets, Figure 1 represents the mass spectrogram of one of them in the wild. As we can see, fake audio cannot reproduce the detailed structures that are close to those in the real audio mass spectrograms. Thus, in this research, we aim to leverage insights from these data sets to comprehensively evaluate deep learning model generation capabilities for detection fake audio. To evaluate the performance of deepfake audio classifiers, we plan to use an equal error rate metric, which is defined as an error rate at a particular special operating point at which the false alarm and miss rates are equal. It is independent of decision costs and does not necessitate the predetermined setting of detecting thresholds. Considering the current state of deepfake audio detection field, we can say that the ASV spoof 2021 dataset is central to deepfake audio detection, with RAW-Net2 emerging as a leading model. However, RAW-Net2 limitations in generalization beyond controlled datasets raise concerns about its reliability in real-world scenarios. Understanding RAW-Net's details and enhancing its generalization capabilities are crucial next steps in improving deepfake audio detection. As was said earlier, one of the most promising baseline model from ASV spoof is RAW-Net2. Its architecture is illustrated in Figure 2. RAW-Net2 is fully end-to-end system that operates directly on raw audio waveforms. As a feature extraction layer, it uses sync-conv filters with different resolutions. However, due to its design, the sync-conv layer can be limited in capturing all small-scale features. It operates as a band pass filter with fixed time frequency resolution, which may not fully capture the nuanced characteristics of fake audio signals. This limitation could potentially impact the model's ability to distinguish subtle differences between fake and real audio. To address this issue, a potential avenue for improvement involves exploring alternative feature extraction layers. Currently, the model relies on sync-conv with 20 filters for this purpose. A possible solution to improve generalization capabilities is incorporating the wavelet functions into sync-conv filters. Figure 3 illustrates the proposed neural network architecture, showcasing a future extraction layer comprising concatenated sync scale filters, sinusoidal wavelet filters, and Morvalet wavelet filters, also known as Gabor wavelets. The sync, sinusoidal, and Morval filters are defined according to 1, 2, and 3 equations. This integration aims to enhance RAW-Net2's capacity to distinguish subtle differences between real and fake audio signal. It does so by combining wavelets variable time frequency resolution with sync-conv band pass filtering, leveraging the strengths of both techniques. Following the feature extraction layer, the architecture involves two res blocks consisting of residual connection and convolutional layers to facilitate feature learning and extraction. The GRU, gated recurrent unit layer, follows the res blocks, providing providing temporal modeling capabilities by capturing sequential dependencies in the audio data. Finally, a full connection layer aggregates the learned features and produces the final output, which is used for classification real and fake audio signals. Three neural networks were trained for deepfake audio detection using different filter combinations. The first used sync and sinusoidal violet filters, the second used sync and Morlet violet filters, and the third combined all three. The networks were evaluated based on equal error rate. The obtained results showed on the slide. The networks with varied filter combinations outperform RowNet 2, showing better generalization across datasets. The model using all three filters was the most effective, particularly in detecting nuanced spoofed audio signals. The network with sync and Morlet violets performed best on the ASV spoof data, making this approach promising for real-world deepfake detection. To sum up, this study addressed the challenges posed by deepfake audio, focusing on developing neural networks with high generalization capabilities. We propose a null approach that combines sync, syn violet, and Morlet violet filters in the feature extraction layer of the RowNet2 architecture. Our experimental results demonstrate that the network trained with these combined filters showed better generalization capabilities across diverse datasets than the original RowNet2 architecture. However, it's worth noting that the proposed networks don't show high generalization performance on all datasets, suggesting that the future research and refinement are necessary for optimal performance across all datasets. Future work will focus on exploring optimal combinations of violets for deepfake audio detection and exploring other variations or combinations of filter to improve detection accuracy. By continuing to refine and enhance detection systems, we can better safeguard social trust and security against the risk associated with deepfake audio technology. Thank you for your attention, and also I want to say thank you for organizers to give me a permission to take part in conference online.
Thank you very much for your talk. Thank you very much for your talk. So are there questions in the room? Maybe questions online? We have a couple of people online. Okay. Yes.
Oliana, thank you very much for a nice presentation.
Thank you.
Could you please elaborate a little bit more which sorts of applications these days could be envisioned based on your approach that you have reported?
You asked me where can use this?
Where can you use your solution when it is ready for use? I mean, in real life.
No, first of all, it might be in a bank authentication system, voice authentication system. Also, it's important to use such system to fight with misinformation in social media. It's maybe two approaches that I can think.
Any applications to Miltech, if I may ask about that?
I think yes. For some, I don't know how to be in English, in some control system where the something like in bank was authentication system, but for system for military to control some military equipment, something like this.
Okay, thank you very much.
Thank you.
Any other questions? Yes.
Hello. I have a question. Did you look into semantic or maybe mood analysis based on voice characteristics during your studies?
No, unfortunately, I didn't take attention on this.
Okay, thank you.
So one question I would have is, has these also been compared to human evaluators maybe? So whether these can also distinguish between fake and real audio data, or is this still already indistinguishable for humans?
Thank you for your question. If you hear fake audio, human eye represent it as real. We can distinguish them. We can distinguish fake and real based on a human heart system.
Okay, thank you. And another small question. You said that it works better on some data sets and less good on other data sets. Have you maybe an idea on which data sets it works particularly well and on which rather not so good?
First of all, if the data is so noisy, it perform worse on it. Also, it perform worse on data that it didn't see during the training. It's two suggestions. Also, there are data set that obtained in the wild using different codecs, and this data is also hard to distinguish.
Okay, thank you very much. Are there any?
One more question. There is a bunch of startups that are recording voice of, I don't know, coaches or trainers or lecturers and make virtual video presentation for them, like Character AI and others. Did you try to test audio produced by these startups against, could you detect, is it real, and how real, could you assess how real is audio of every startup that is produced?
Thank you for your question. Unfortunately, no, but I plan to do it in my future researches.
Okay, last question maybe.
Thank you for the presentation. Could you please answer about your data sets? Are you testing fully deepfaked audio, or are you using some mixed, for example, some origin that part of it is modified by deepfake?
Part of them was modified from real, and part of them was totally fake. For example, that was generated by text-to-speech methods.
Okay, thank you again. Let's thank Uljana again. And
Thank you.
thank you. And then the next talk will be by Serhiy Savchenko and Vitaly Kobets. And I think Serhiy will present. Okay, and the title of his talk is Allocation of Investment Portfolio Asset Classes Using Machine Learning. You can start it. Yeah, I think.
Hello, everyone, dear chairs, dear participants of the PhD Symposium of the ICTERI conference. My name is Serhiy Savchenko, and I'm very pleased to participate in this event. Let me introduce the research data analysis for prediction stock. Oh, I'm sorry, I have some small issue. No, it's okay. So the allocation of investment portfolio asset classes using machine learning prepared by me and my scientific advisor, Vitaly Kobys from Kherson State University, Ukraine. So I would like to present the structure of the research. First, I will discuss the motivation behind the research we conducted. I will provide a brief overview of the machine learning techniques we selected to the task of allocating shares of different types of financial instruments in using in a portfolio for a novice investor. And next, I will provide a brief overview of the experiments we conducted using mentioned machine learning techniques, and we'll analyze the results of these experiments and explore potential paths for further development of the research. The financial world is rapidly evolving with a growing demand for automated finance management services, and a key challenge in this field is creating personalized investment portfolios that align with individual investor profiles and risk preferences. And traditional methods often cannot effectively meet these needs, as it requires a significant amount of time to be spent on each individual client. And we believe that automation of process related to a personalized approach plays a key role in modern robo-advisor applications. Traditionally, portfolio management has relied on theories like Markowitz mean variance model. However, the integration of machine learning in finance has opened new possibilities. And most existing approaches focus on forecasting the prices of financial instruments based on historical price changes. But selection of an investment portfolio in this way doesn't take into account the personal preferences of the investor and his or her subjective beliefs about certain classes of financial instruments. And our research aims to develop machine learning models capable of generating personalized investment portfolios. Our objective was to compare the effectiveness of various ML algorithms, forecast the allocation of financial asset classes, and evaluate the practical applications of our approach as a model within a robo-advice service. The novelty of this approach lies in forecasting the shares of financial asset classes based on a real data set of various characteristics of new investors, as opposed to existing studies that focus on rebalancing an already existing portfolio. Our approach offers the advantage of forming an initial investment portfolio based on investor characteristics rather than solely based on return and risk on financial instrument, and the investor's risk appetite, which is predominant in the traditional approach to portfolio formation. The research is based on a publicly available dataset by Objectway Finance software. The dataset includes information about more than 100 anonymous bank users and portfolios they have chosen with the help of professional human financial advisors. Information about user includes sex, age, region of residence, investment goals, temporal goals, financial experience, etc., and of course the risk preference. Information about users' portfolios includes volume and identifier of each asset included in the portfolio. Each asset consists of one or more asset classes. If the asset consists of more than one asset class, the percentage of each asset class is indicated. The assessment of investor risk profiles was conducted using the Schubert method. This involves a 25-question assessment with responses scored to categorize investors into different risk types. This assessment is crucial for tailoring portfolios to individual risk preferences. Another key step was transforming the portfolio's data into a format suitable for our ML models. To reduce the dimensionality of the output array that will predict, we transformed the investment portfolio from an asset share view to asset classes shared view. The total number of unique assets is more than 1,000, and the total number of asset classes equals only to 20, which is much less than the number of all assets, and full data transformation process is presented on the slide. During the experimental part of our study, we applied several machine learning algorithms, including Google Simple ML as a benchmark, long short-term memory neural networks, regression trees, random forest, and multiple linear regression. Google Simple ML is a free extension for Google Sheets that offers automation of many steps of the machine learning process, such as model selection, hyperparameter optimization, and building the model itself to make machine learning more accessible to a wider range of users. And we use Google Simple ML as a benchmark, representing a no-code approach accessible to non-experts. We used its predict missing values task type with the gradient boosted trees algorithm, making separate predictions for each asset class here. And here you can see that since Google ML does not allow selecting multiple columns as a target value, we made separate predictions for each share of the asset class in the portfolio. This is columns from A1 to A20. And in the simple ML settings, we choose the predict missing value task type and the gradient boosted trees algorithm. So you can see that the value of our predictions, while approximating to 1, does not equal it. Negative values also occasionally appear in the prediction result of Google Simple ML. And to address this issue, we, in the row output data, the following data modifications we made. If the value is less than 0.01, it is set to 0, and each asset class's fraction is divided by the current sum of all portfolio fractions, resulting in the total sum of all portfolio fractions equaling to 1. Another ML algorithm is long short-term memory neural network, which are particularly interesting due to their ability to process complex sequences. And a long-term short memory neural network is a type of recurrent neural network that has a special architecture of hidden layers. We have previously used LSTM in our robo-advisor model for price forecasting, so we were curious to see how it would perform in portfolio generation. Our LSTM model used a single hidden layer with 64 LSTM units and 12 dense units. The next is the regression tree, which is a type of decision tree, which is specifically designed for predicting numeric values. While classification trees assume categorical labels, regression trees assume a numeric value for each input instance. And the algorithm of the regression tree recursively splits the dataset based on the features to create a tree-like structure. The leaf nodes on the tree represent the predicted numeric values for the input instances falling into that leaf. And regression trees are appropriate to use when the relationship between the input features and the target variable is non-linear, or when input data consists of different data types. And multiple linear regression, while simpler than other methods, offers the advantage of clear interpretability. It is a statistical technique used to analyze the relationship between a dependent variable and two or more independent variables. So I'll move to our experimental part. The process of data preparation is the same for all algorithms and includes checking for the absence of null values, data normalization of all independent variables, and the dataset was divided into training and test parts in the ratio of 70 to 30. And two indicators, the root mean square error and accuracy according to the confusion matrix, evaluated the efficiency of each algorithm. Since our experiments used to predict the distribution of shares of different asset classes in the portfolio, we introduced following rules for determining true and positive entries. True positive if the share of the asset class is in the prediction differs from the value in the real portfolio by less than 10%. True negative is the share of the asset class in both the prediction and the real portfolio is equal to 0. False positive is the share of the asset class in the real portfolio is equal to 0, and in the predicted one is more than 0. And false negative in case when the share in the prediction is less than the share in the real portfolio by more than 10%. The experimental part of the research was performed using the Python programming language and open source libraries for data processing and machine learning. The main task of the experimental part was to identify the machine learning algorithms that show the best results in terms of root mean square error and best accuracy. The results obtained using Google Simple ML were also separately compared with other machine learning techniques. The table of this slide displays the root RMS estimates for portfolios compiled using the Google Simple ML, multiple linear regression, LSTM, regression tree, and random forest algorithms. And multiple linear regression and regression tree with automated hyperparameter tuning and random forest with automated hyperparameter tuning give the best results with the least RMSE. And when we look at the confusion matrix results, we see that random forest achieved the highest accuracy at 46%. Although the random forest model received the worst RMSE score, it has the best accuracy among other algorithms.
3 minutes.
Mm-hmm. And in terms of accuracy, almost all manually programmed ML models demonstrated better results compared to the Google Simple ML service. In this study, the accuracy is prioritized over other metrics, such as RMSE, because this choice aligns with our goal to automate the creation of the initial investment portfolio, and the focus on accuracy is warranted by the expectation that user will lately modify their portfolios according to their personal preferences. Portfolios built using the LSTM and Google Simple ML models performed worse on both evaluation criteria, and this result can be explained by a small dataset sample and the clear predominance of the importance of some input features over others. Prediction algorithms based on linear regression and decision trees are the best ML techniques when the training data set is limited. And this study examined machine learning methods that can be applied to the task of determining the initial allocation of asset classes in the investment portfolio. The study analyzes different machine learning methods that require manual programming in comparison to the Google Simple ML service, which is a no-code solution. Our random forest model provides the most accurate allocation of asset classes in the investment portfolio, despite the fact that the accuracy of this model is less than 50%. Automated machine learning tools have even lower accuracy, which demonstrates the advantage of developed ML methods over the automated ones. So in the course of further research, it is planned to conduct experiments on training machine learning models on a more detailed dataset, which, for example, will include specific user responses in questionnaire rather than just a general assessment of risk attitudes using the Schubert methodology. And another promising area for the future research is the possibility of using large language models to analyze trending financial instruments, which is called market sentiment analysis, and try to identify hidden investor behavioral insights. That's all. Thank you for your attention, and I'll be glad to answer your question.
Thank you very much for your talk. So, do we have questions here? Don't know who.
Okay, my question is, how many classes do you have? Yeah.
So in our dataset, we had 20 asset classes. It's like stocks in different, for companies in different areas like IT, agriculture, and so on.
Do you have suggestions or hypotheses why is the accuracy so low? Because usually random forest is much better.
Yeah, so the main problem is that we have tried to generate the whole portfolio. So basically it's like an array of 20 values, and we should predict each share very with a big accuracy. I mean, so this is and also that our dataset has only a bit more than 1,000 examples. I think that we just can train models.
Yeah, this can be done because obviously if you don't have data, you can't get enough accuracy. Okay, I just suggestion also consider other useful metrics. For example, F1 score is like standard for such kind of problems. Also ROCAUC, you can try it, and other, because maybe you just calculate, maybe you choose wrong metric to optimize. Okay.
So any other questions? So okay, any question in the online? Okay, the one question is of me would be, so you use the confusion matrix accuracy, but that's a metric for categorical outcomes, and you somehow transform the predictions into something categorical. Is there a reason, a specific reason to do that, or not just use a metric for a measure for metric outcomes?
Yeah, as we try to predict the asset classes share in the investment portfolio for each asset classes, and the total number of asset classes is 20. We've tried to find a good way to analyze our results, our predictions. Because, for example, if one asset classes in real portfolio has a share 16% and we predicted 15, is it correct or wrong prediction? And so we define some rules for our confusion metrics to.
Yep. But still, so in the end, you want to do some classification, then so say that it has a positive share or zero share. Maybe for that application, it would it's good to have to transform this into a classification problem.
Yeah, it's basically it can be present like a kind of recommendation system, which input parameters are users some characteristics like sex, age, and others, and the system should give him or her recommendations about some asset classes that might be interesting for him or for her. So it's maybe we should continue on our work on this course, and will give better results using other methods.
Okay, thank you. So there's also a random forest version for bounded outcomes, because I think the shares are between 0 and 1 or 0 and 100. Yeah, I know that because I do a lot of research on random forest. There's a version of random forest for bounded outcomes. but I can show that you that after the session. Okay, then let's continue with the next talk. And thank you again.
Thank you. Thank you.
Microphone. Yeah. Okay, the final talk will be given by Alexei Ivanov, who did this work with Vitaly Kobets, and the talk is titled Integrating Semantic Analysis and Financial Indicators of Business Reports for Predicting Stock Prices. So you can start. Can you try again? Or yeah. I think it takes 2 seconds.
Okay.
Maybe
Okay, thank you. Okay. Dear Chair, dear participant of the PhD Symposium of ICTERI conference, my name is Alexei Ivanov. Let me introduce the research integrating semantic analysis and financial indicators of business reports for predicting stock prices by me and my scientific advisor, Vitaly Kobets from Kherson State University. I'm very glad to take part in this event. On this slide, you can see the outline of our research, which includes introduction, related works, methods, results, and conclusion. Quarterly financial reports, known as 10Qs, often lead to significant changes in companies' stock price. This is because the reports not only show financial performance, but also include management's outlook. To better understand these impacts, we use Finbert, a specialized NLP model for the financial sector, to analyze the sentiment within these reports. Our goal is to combine sentiment analysis and financial indicators from the report to analyze their impact on stock price movements. In financial data analysis, and financial indicator forecasting, numerous studies have been conducted. We considered some of them, namely in the article Data-Driven Decision-Making in Credit Risk Management, the information value of analyst reports by Reuter et al. Explores the role of financial analyst reports in enhancing credit risk assessment. The authors focus on how sentiment and topic analysis from these reports can provide valuable insight that complement traditional credit risk indicators like credit default swaps. The article Transforming Sentiment Analysis in the Financial Domain with ChatGPT by Fetters et al. Investigates the potential of using ChatGPT, specifically version 3.5, for sentiment analysis in the financial domain, particularly focusing on the foreign exchange market. The article Machine Learning Sentiment Analysis COVID-19 News and Stock Market Reactions by Castola et al. Examine the impact of COVID-19 related news on the financial market during the early stages of the pandemic. Analyzing over 200,000 articles from the major news platforms, the author used a financial market adapted BERT model to extract sentiment. The article, a multimodal model with Twitter Finbert embeds for extreme price movement prediction of Bitcoin by Zhou et al., presents a sophisticated approach to predicting significant price movement in Bitcoin. The authors developed a multimodal model that integrates various data sources, including technical indicators, correlated asset prices, and social media content, specifically tweets about Bitcoin. We extract sentiment scores from quarterly reports provided by these companies to combine it with technical ratios for future analysis to enhance price movement prediction. As data source for our research, we are using 10Q reports. A 10Q report is quarterly filing submitted by publicly traded companies to the US Securities and Exchange Commission. It provides a comprehensive overview of companies' financial health, operations, and risk. These 10Q filings are public information and are readily accessible through several sources. Most companies include them in the investor relations section of their websites. The financial statements include the essential sections: income statement, balance sheet, and cash flow. The income statements summarize a company's revenue and expenses over a specific period, showing whether it's made a profit or incurred a loss. The balance sheet provides a snapshot of a company's financial position at a given moment, detailing its assets, liabilities, and shareholders' equity. The cash flow statement tracks how cash flows in and out of company, categorizing it into operating, investing, and financing activities to assess its cash flow management and liquidity. Management discussion and analysis section offer management's perspective on the financial results, including discussions on factors that influence the performance, trends affecting the business, and future expectations. Risk factors, risks that have emerged during the quarter, which could affect the company's financial health or operations. We developed a script using the Python programming language to automate data acquisition for the selected period and generate the final dataset. We are pulling data from the 3 different sources: Yahoo Finance, Financial Modeling Prep, and US Securities and Exchange Commission. From the Financial Modeling Prep, using their API, we obtain the financial indicators of the quarter reports of the selected company for the selected period in JSON format. Using this resource, we generate the metrics for our final dataset. Using the Yahoo Finance resource, we obtain historical data of the company's closing price as dependent variable. Sentiment analysis starts from pulling 10Q reports directly from the Security Exchange Commission using the URLs provided by Financial Modeling Prep. This report is presented in HTML format. The first step in this process is preparing the text for analysis. This involves removing non-text elements like images, tables, and HTML text, which do not contribute to the sentiment. Using the beautiful soup library, we clean text, ensuring it's ready for accurate future analysis. After preparing the text by removing non-text elements, we use the Finbert model through the Hugging Face service to conduct sentiment analysis. Finbert is a specialized version of the BERT model, fine-tuned specifically for financial texts. It excels at understanding the nuances of financial language, capturing the context in which words are used to provide accurate sentiment analysis. This process generated 3 key sentiment scores: positive, neutral, and negative. We then compile all data into a single CSV file and compare it to datasets, one with only financial indicators and the other combining with these sentiment scores, to determine if sentiment analysis could enhance our prediction of stock price behavior. To determine whether sentiment analysis of quarter report could provide more information about the future behavior of company stock price, we used 2 datasets, one including only financial indicators and the second including financial indicators and sentiment estimates. Table on the slide shows descriptive statistic for the completed dataset. As dependent variables, we examined the closing price of stock at different time intervals after the report's publication. We selected the following time intervals: the next day, 2 days after publication, 7 days after publication, and 14 days after publication. We applied the random forest algorithm using the sklearn library to analyze our data. Random forest was selected because of its strength in handling nonlinear dependencies, which are common in financial data. By constructing multiple decision trees, it captures complex interactions between variables, improving the model's generalization to unseen data. We followed a standard model training approach, splitting our data 80-20 ratio for training and testing. To enhance performance, we used a grid search CV, which iterates over a range of parameters and employs cross-validation to find the optimal settings. This step was critical in optimizing our model accuracy and reduce overfitting. While evaluating model performance, we utilize root mean squared error, percentage deviation, and R-squared. The table on this slide shows the models combining financial indicator with sentiment analysis through Finbert, demonstrate better results than model based only on quantity data. Enabling sentiment analysis significantly reduces root mean square error, improving forecast accuracy, especially for medium and long-term periods. In addition, the slight improvement in the coefficient of determination. When adding sentiment analysis confirms that such models better captured the dependencies in the data. But overall, we can say that the improvements are insignificant. The same conclusion can be drawn from the importance ratings of independent variables. We can notice that sentiment rating had the lowest importance ratings. Only the negative rating had a minor impact. To conclude, to analyze the sentiment of 10Q reports, we used the Finbert model, which provides some insight but showed minimal impact on accurately predicting stock prices. Our model performed best on the 7th day after the report's release, achieving strong metrics such as RMSE of 2.726 and R-squared of 99%. Given the limited influence of Finbert's sentiment scores, our next step will be explore newer sentiment analysis models like ChatGPT, which might offer improved accuracy in capturing financial text nuances and enhancing our predictions. Thank you for your attention. I will be glad to answer your questions.
Maybe it's working.
Okay, thank you. Yeah. Thank you for your talk, Alexei. Do we have any questions here? Yeah.
Thank you. What is your future plans for pulling data? You used only these reports. Do you have any other plans to pull data?
No, I don't have plan for using other things because actually all data which we can see in other resources are based on this report. I mean, this report contains all indicators of company and, like, for example, any financial indicators which we can pull from this report, like revenue, I don't know, their liabilities, what operations income, and so on. So most of the data which I saw is based only on this data, if I answer correctly.
So you basically concentrated on financial reports and financial indicators?
Yeah.
Okay. And is it like pilot study or is it PhD project or what kind of?
Like it's part of my PhD project, but for now it's just a pilot to try it.
Mm-hmm. And any other future directions, except that you mentioned use ChatGPT for sentiment analysis?
So future direction is try to work more with indicators from this report, not only sentiment analysis from this report, because my approach was the main that in these financial reports, their outlooks can give a lot of information. For example, by indicators, they can perform good. For example, they have a high revenue and so on. But for example, if manager expects that in the next quarter, they will have less revenue and less income, it can affect stock prices in future. But by indicators, we will see that that all is good with company. But by manager's outlook, if we read it, we can expect that stock price will go down. So the main approach was this one.
Mm. And what is your PhD project topic?
PhD project is to build information system for analyzing stock price, not stock prices, analyzing public companies, their like how they're performing and so on. I mean, this information system should give to user ability to see the main indicators of this company and like to give them better understanding how this company can perform in the future and use it for investment or not.
Okay, thank you.
Any other questions? So one question I have, so you have a positive score, a neutral score, and a negative score.
Yes.
So if a text is very positive, then it's also less negative. So I would assume that the two correlate strongly negatively. So did you observe that in your data?
Yes. In our results, it shows that it's more natural text because it's not unemotional. It doesn't have any emotions in this text. But I guess it's more related to model which we used for invert. Probably we need to try with another one model. Maybe it will take better results for, and we'll find this scores better. I mean, it will be more significant values.
Because if they strongly correlate negatively, this could also impact the model in some sense, because if two variables very strongly negatively or positively correlate, then they somehow, the model does not know anymore which model is, which of these two variables is important, and then it may also make sense to only include the positive score and maybe try out to leave the negative score. Do you think that could be something to try out?
Yeah, maybe we can try to use only one score of, like maybe only with positive or maybe only with negative score and so on.
Okay,
Thank you.
Thank you. Any other questions? Okay, online, does online somebody have questions? Okay, if not, then yeah, I also don't have any questions more. Then thanks again to all the speakers, all the three speakers and the discussions we had here.
Thank you.
Okay, yeah, I don't know who will speak some words, but probably.
Before we call it a day, ladies and gentlemen, I would just announce that we still have two important events today. In about 11 minutes from now, we'll be closing the conference, so you're welcome to stay and join us in the fest. And after that, we'll have the very last coffee break. So this is the agenda for today, and the conference will be over. Thank you very much for coming. Thank you very much for fruitful discussions and very nice presentations. We are honored as the members of the organizing committee to have you all here for a very good conference, as I believe you share this opinion by the hosts. So thank you very much. and enjoy the rest of the day before calling it a day.
Okay. So this is the end. Last but not least, I want to thank you for participating in actually this conference, in all of this event. I think like this was very nice for the reason that like there is no so many like actually offline conferences here in Ukraine nowadays, and that was like important for us to organize like that's really offline. And I think like that's a lot of interesting connection happening, at least for me. I've like meet my good friends like from all around like Ukraine and abroad. So, and like meet new people, that's like actually two important things like for a conference to actually meet new people and like also meet old like good friends like on the conference. So I'm really happy that like we organize that in a way that how it went. And I'm really happy that the next conference like is already planned. And I'm transferring like my word like to Vadim to actually pass the next I don't know like conference symbol to the Italy, I don't know like, or where like we will have in Italy. Yes. Oh no,
Just a 2-hour ride from Italy.
2-hour ride from Italy. Sorry.
Through Monaco.
So, oh, that's nice.
Okay, and thank you very much. In my free interpretation, the Chinese say that the end always starts a new adventure. So I'm looking forward to seeing that you follow us in this new adventure and submit to the next ICTERI conference, which will be not in Italy, but in France, in Côte d'Azur. L'Université de Côte d'Azur will be the host. It will be at the very beginning of September next year. So please do your research. Please write good papers. Please submit. The only thing I can promise that the review process will be very competitive. So write good papers. We're looking forward to all of you, meeting all of you over there in Nice at a very nice place, and for even more great ICTERI 2024. Thank you very much, and have a safe trip back.
Yeah, all good things.